The next limit solving strategy that we are going to learn is the squeeze theorem. The squeeze theorem says if f of x can be sandwiched between two other functions, g of x and h of x, and g of x and h of x meet at the limit index, then the limit of f of x must equal the same as the limit of g of x and the limit of h of x. So take a look at the picture to get a better idea of this concept. If g of x is always above f of x and h of x is always below f of x except at x equals c, which is where they meet, then I should be able to find the limit of f of x by matching the limits of g of x and h of x. That's the basic idea. So tips for using the squeeze theorem. First, if you are asked to find the limit of a trig function like sine or cosine, remember they have range limits of -1 and 1. Second, if you have a limit function that will not work with the setting at -1, 1 range limits, try using geometry instead. On this video, we will only look at the sine and cosine in the first tip. We will look at the second tip in class. For the first example, we will use the limit as x goes to 0 of x squared times the cosine of 1 over x squared. Now this limit will not work as is because 1 over x squared becomes infinity at x equals 0, and cosine of infinity just doesn't work. So get your calculator, yes, I mean the dreaded Casio, and go to the graph screen. Also, don't forget to make sure the calculator is in radians, and you can do that by pressing Shift menu so you can get to the setup screen and scrolling down until you find the angle setting. Once you finish that, for y1, type in x squared cosine of 1 over x squared. Now the 1 over x squared needs to be in parentheses or it'll screw up on you. Now we know that cosine has a max value of 1 and a minimum value of -1. So I'm going to say that cosine of 1 over x squared must be between -1 and 1. Now our actual function also has x squared in it, so I will multiply my bound relation by x squared to compensate. And I'm multiplying everything by x squared. Now I have my x squared times cosine of 1 over x squared sandwiched between -x squared and positive x squared. On your calculator, make your y2 equal to -x squared and make y3 equal to x squared and press F6 to draw it. Check the graph. Is x squared times cosine of 1 over x squared sandwiched between -x squared and positive x squared as it's leading up to x equals 0? This means we can continue with our sandwich theorem. So we find the limits of -x squared and positive x squared first. And we're doing this so we can check if they match. Since they match, and x squared times cosine of 1 over x squared is sandwiched between them, we know that x squared times cosine of 1 over x squared must have the same limit. So in this way, we have proved that the limit as x goes to 0 of x squared times the cosine of 1 over x squared must equal 0, because we have sandwiched it between the functions -x squared and positive x squared. For our next example, we will use x squared times e to sine of 1 over x as x goes to 0. Just like the last example, we are going to start with the limits of the trig function. Sine has limits of -1 and 1, so I will say -1 is less than or equal to sine of 1 over x, which is also less than or equal to +1. Now I'm going to raise everything as an exponent of e to start matching my original function of x squared times e to the sine of 1 over x in my limit. After I raise everything, I will multiply x squared to also, just like I did in the last one, to finish the process. Now at this time, please use your calculator to verify our claim. Set y1 as x squared times e to the sine of 1 over x. Set y2 to x squared times e to the -1 power. And set y3 as x squared times e. Pause the video until you can verify it. Does x squared times e to the sine of 1 over x power get sandwiched between x squared times e to the -1st power and x squared times e? Then we can continue. The limit of x squared times e to the -1 as x goes to 0 is 0. And the limit of x squared times e as x goes to 0 is also 0. So we can say that the limit of x squared as x squared times e to the power of sine of 1 over x is also 0. And we know this since we've already proved that x squared times e to the sine of 1 over x power is sandwiched by x squared times e to the -1 power and x squared times e. Wow, that was a mouthful. Alright, review the sandwich theorem and how it works. Double check your notes to reflect, and if you did not take notes, watch the video again.